Lars Brinkhoff is going to talk to you today about ITS, Incompatible Timesharing System. I have no sense of humor, so when I was reviewing this presentation, I asked him what it was incompatible with. He will explain that to you. Thanks. Lars?
Okay, so I'm Lars Brinkhoff. I'm here to talk about ITS, which is the Incompatible Timesharing System. A little overview. I'll explain what is ITS. I'll talk about its history and the particular values, features, and a little bit about what we're doing today. And I'll finish off with a little demo. Here are just some topics that surround ITS. I will not be able to talk about all of them, but you're free to ask me later, and I'll be happy to talk your ears off. First, who am I and why am I doing this? I started with a VIC-20 computer as a kid, and I went to the library for all the books about computers, and I read this particular one, The Hacker's Dictionary, which is written by one of the guys who were programming ITS. And later in my professional life, I added support for the PDP-11 video computer to new tools. And after that, I helped adding PDP-10 support to the GCC compiler. So, first of all, what is ITS? It's an operating system for the PDP-10 mainframe. It was written at MIT in 1967, and it was kept running until 1990. So that's a pretty good span for an operating system. It's known for its wide openness and lack of security. So, what is the PDP-10 computer? It was made by Digital Equipment Corporation. The first version, the PDP-6, came out in 1964. And it was supported until around 1988. There were 5 generations. First, the PDP-6, and then 4 generations of the PDP-10 processors, KA-10, KI-10, KL-10, and the small KS-10, all of which are available here at the museum. It was designed with Lisp in mind. It had a 36-bit word length and 18-bit addresses. So it can fit 2 addresses in one word, which is known as a cons cell in Lisp. That's a large, orthogonal, nice instruction set, and it has a pleasant assembly language. So it was very popular among programmers and hackers, and in particular on the ARPANET, which is the forerunner of the internet. And I tried to squeeze in a picture of a PDP-10 there. It's a little bit small, so it's better if you take a look here at the museum. There were some other operating systems at MIT before ITS. There was an artificial intelligence group that formed around 1959, which were to later create ITS. And there was a large IBM time-sharing system, the one to the left, called CTSS, which is the Incompatible Timesharing System. So that's the explanation. The programmers who made ITS made a pan on the CTSS system. And later, Project Mac was started, and they created the operating system Multics. The picture to the left is from the first Multics machine. So, ITS was created by the AI group at Project Mac for their PDP-6 computer. The picture to the left is that computer, much like the one downstairs. And at first, the PDP-6 was used in single-user mode. And there's a clear progression from those single-user tools to ITS, which I'll show later in the demo. ITS was created as a sort of alternative to CTSS and Multics. In the picture to the right, there's a file from ITS. The text says, "Happiness is not used in Multics." So that was kind of the attitude among the AI lab towards Multics. ITS is a little bit special because it was written by hackers for hackers, and they didn't want anything like get in the way of getting work done. Multics, on the other hand, was planned and implemented for years, but ITS was implemented in something like 6 months. Also, it's very interactive. Programs will usually respond on single key presses. This was in contrast to the CTSS operating system. It was somewhat sluggish. At first, and for a long time, there were no passwords whatsoever and no file provisions, so everything was wide open. And there was source code for almost everything, but easy to plunge in and hack the system. And guests were allowed onto the system and even encouraged in some cases. So, after the initial phase, there were some early developments. The AI group got their PDP-10 computer around 1968 and ported ITS to that computer. The picture to the left, that's the best picture of the AI PDP-10 I have. It's barely visible behind that teletype. A few years later, they added virtual memory with special hardware to their computer. And soon the computers were connected to the starting ARPANET. And other groups outside the AI group got their own computers. The one in the middle is the dynamic modeling group, PDB-10. The man in the picture is Lick Leiter, who was the boss of that group and a great visionary. And the picture to the right is the ML machine, which is Math Lab. The bearded man is Joel Moses, who was a researcher in mathematics, symbolic calculation. And the other man is Patrick Winston from the AI group. These machines, 3 at this time, were heavily used for research. First and foremost, artificial intelligence. There is also robotics and computer vision. The Logo computer language started at IBM, but soon moved to MIT. It's famous for the turtles in that picture. Lisp and the Lisp dialect scheme developed a great deal on these computers. And the first Lisp machine was made in this AI group. There's Tom Knight and Richard Greenblatt proudly presenting their Lisp machine. And Joel Moses from the previous slide was the initial creator of the Maxima mathematics manipulation program. Lick Leiter's group also strayed into programming technology research and were the first to connect the PDB-10 to the network ARPANET. The machine in the ugly green room is an INT, interface message processor, which is kind of the router at that time for ARPANET. The mid-70s were a period of great development for ITS. They added a networking file system that were able to send data through the ARPANET between these 3 machines. It may be the first network file system. They added memory mapped, bitmap raster displays, like in that picture to the left, with special keyboards similar to the famous Space Cadet keyboards. In 1975, they bought a 4th machine, which was the latest, greatest, fastest processor at that time. And we have a picture to the right. 1 year later, the still popular editor Emacs was created on this operating system. And they kept up with networking technology and added TCP/IP in 1982, shortly before the ARPANET switched over. Some of the famous programs created on ITS is MapLisp, which was their dialect of Lisp, and very influential on Lisp dialects after. I already mentioned Maxima and Emacs. and scheme. Then there were, I'm not sure I'm pronouncing this right, but Shrew, which is famous for parsing natural natural English sentences, and were able to manipulate a virtual world filled with boxes and pyramids. And you were able to command it to move things around and ask questions in natural English language. And finally, there were a model, which was the programming language most famous for implementing the game Sword. They had plenty of games. Base War was invented at MIT on the PDP-1, and of course has support to the PDP-6 and 10. There was the Greenland chess program, MagHack6, pictured to the right. There was a flight simulator. You see 9 gauges in another picture. There was the adventure text game, imported from elsewhere. Maze War was the first-person shooter game, and it developed greatly at MIT. There's a mostly forgotten game called Dazzle Darts, which is the black picture over there. They had Moonlander running on a PDP-11, and like I said before, the Zork game was developed on ITS. There was also a lot of MIT also cooperated with other PDP-10 sites and imported many other programs from other sites. There is an emulator for TOPS 10, which is DEX operating system, and Weights, which is the operating system used at the Stanford AI Lab. So from DEX they imported many tools like the assembly language, linker, Fortran compiler. And from Stanford, they imported their tools, so spelling checker, DOTS, which is a CAD program, the one to the right, Tech and Pub, which are typesetting software, and Geomed, which is a geometric editor for 3D models. And from CMU, they imported Scribe, which is another typesetting program. The PDP-10 computers weren't running in isolation. They had many other processors attached. The AI PDP-10 had the old PDP-6 still attached, running standalone. There were many PDP-11 mini computers managing the peripherals. There was the first list machine prototype called CONS, also attached through shared memory to the PDP-10. There was a chess machine called Geox, and a GT40 PDP-11 with a vector display to the upper right, running Moonlander. And the dynamic modeling group and many inlet computers which were used to run the maze board game, and other things, of course. And for all of these computers, there were tools and software, so ITS was kind of the development environment for these smaller computers. So there are some special features and limitations in ITS. One of the most cherished features were PC illusory, which is kind of hard to explain quickly, but it means that no process can see another process in the state of executing somewhere inside a system call. So it means the PC, the program counter, is either before the system call or after it. Much like the proc file system on Linux and other Unix operating systems, processes and even processors are available as files. One thing that's immediately apparent when you log in is that you end up in a debugger, which was kind of the perfect user interface for hackers. Many of the applications are quite similar to Emacs in the user interface. There are a lot of single key press commands and control and meta combinations. They had user space device drivers and real-time scheduling. ITS was early to have terminal independent text output, much like cursors for Unix. However, there was just one level of directory structure, so there could not be a directory inside another directory. And also file names have a maximum of 6 and another 6 characters. The 1980s were a period of decline for ITS. The old PDP-6 and the 3 first PDP-10 computers were no longer able to maintain and were scrapped. However, ITS was ported to the KS10 processor in 1985. And actually, the KS10 processor that ran ITS last at MIT is in that picture, and it's right here in the museum, and you can see it in the machine room. The great KL10 machine was shipped off to Sweden, and if you've been to the basement, it's there now. And finally, in 1990, the last ITS machine at MIT was shut down. We have some aspects of ITS still with us today. Richard Stallman worked a lot on this operating system, and he was probably greatly inspired by the freedom and openness. He wanted to reiterate that in the GNU project. Of course, Emacs was also created largely by Richard Stallman, and he made a new version for Unix. The info system in the GNU projects is also pretty much a copy straight from ITS. The Whois service doesn't come from ITS, but their name probably does, because there was such a command in ITS. Two important Lisp dialects today, Emacs Lisp and Common Lisp. They're very similar to Mac Lisp. And the peculiar meta key is still available on some keyboards. And I like to think it's much because of Emacs. I have to admit it didn't originate at ITS, but at the Stanford AI lab. Unix job control was added by an ITS hacker missing those features from ITS. And similarly, the more utility in Unix is also pretty much copied from ITS. But there is a new hope. ITS came up on an emulator, PDP emulator in 1992. Someone had an ITS on the internet in 2001. People prepared the public ITS distribution available for download. Disk images you can just run with the emulator. There are many Unix tools for dealing with ITS files and network protocols. And a few years back, I and a few others started a restoration project for ITS. And in that picture is an FPGA running ITS. So a little bit about this restoration project. We create an ITS system from scratch by first putting a few programs of a magnetic tape image. We use that to create a file system on a simulated disk, and then load all the source code and build a new version of ITS and assembler. And then we reboot to run that newly built ITS, and then build the rest of the system, which is over 300 programs. We made many bug fixes, and we use some modern development philosophies like issue tracking and continuous integration. And there's a repository on GitHub with all source code and scripts and everything you need to run ITS for yourself. Okay, time for a little demo. We'll first start into disk dump, which is kind of the loader for standalone programs. As an example, I run the mlife, one-way game my life implementation. Then we'll start ITS for real. I'll show Emacs and a little assembly language programming. We'll try it out in DDT. And then I'll run the PDP-11 logo. And finally show a little bit of Maxima. So this is just my terminal window on my Linux computer. This is the GitHub repository, top-level directory. And there is a start script, which is convenient to start the emulator. So the first thing that happens is that we enter this dump. This is kind of how it was done before ITS was created. Here's a file listing. These are all standalone programs that run without ITS. As an example, I show you Hive. This window is a simulation of the 340 display. We have one downstairs by the PDB6. I'm just making some dots for Hive to calculate on. So this is an example of a simple standalone program that runs without ITS. Now I'll start a few other windows too. The black window is a simulation of the raster display system with night TV display. But first, I'll load ITS, and nothing happened. What happened is we landed straight into DDT, which is the debugger. So we have full access to ITS internals. And we can see memory and instructions. We can set breakpoints and so on if we need to debug the system. But for now, we are just going to start ITS. So what happened here is that in addition to the PDB-10, we have a PDB-11 emulator that is running the night TV display system. So the black window now has a kind of splash screen for ITS. Now I log into ITS. It's a good idea, but not necessary to log in with your name. And many commands are a little bit backwards. So I type my name first, and then Alt mode U is the login command. Here we have the same directory as we saw in this dump. This is the IDS view of the same directory. Here is Emacs, the original, the very first version of Emacs, and it's much the same as today. Here's the info system with documentation for much of the system. It's very much like how it's used today in the GNU system. Here's a little Hello World assembly language program. First thing is to open a channel, which is much like a Unix file descriptor. Then we have a little loop that fetches byte by byte, character by character from the string, writes them to the channel. If you're familiar with Emacs from today, you know there's a metax compile command, and it's available here too. Now the little Hello World application has been assembled. Here's my source code, and the bin is the binary file. We can create a new job, which is exactly like a process in Unix, except processes or jobs don't have numerical IDs but names. So I could create a hello job. Now I can load the binary file. And we can start it from the beginning and single step. Here's the open system call, which creates a channel. We can single step and just run it to completion. Hello world. Now I'm going to show you 11 logo, which is a logo for the PDP 11 computer. And it turns out ITS has a PDP 11 emulator. We're going to load the PDP 11 logo into that and run it. The emulator displays on the simulator 340 display. We have 3 quadrants for the simulated logo displays, and the lower right quadrant is for the simulator information. There's a command to start the display, and as a result we see a little turtle cursor. We can draw using turtle commands. and so on. Finally, I'm going to show Axiom. And for this, I'm going to use plain old Xter in its Tektronix emulation mode. I telnet into the simulator. This looks a bit weird because the terminal is set to be a DT. I need to set it to Tektronix mode first. Sorry, it's not over here. There you go. So, we see we can enter some mathematical expressions and have them nicely formatted. We can solve for x and get 3 solutions. And we can have nicely formatted mathematical problems. And we can do 2-dimensional plots. And 3-dimensional plots. This is done using Tektronix graphics. So that concludes the demo. And the last slide is the command for logging out of ITS. Okay, any questions?
So Lars, my question is, with ITS, there's no security built into it. When the public system was put onto the internet in 2001, was it a target for hackers trying to shut it down, and how do you protect your ITS system from wanting it to be available as a public access system?
Well, the question is, when ITS was connected to the internet in 2001, was it the target of hacker attacks? Well, no, and the situation was much the same as when the ARPANET community developed, because at that point, ITS was kind of forced to adopt passwords. So there's a password facility, and it was used in the 2001 ITS. So I suppose there were no serious intrusions. So how fast is the emulator? I'd say the emulator is on contemporary hardware today. It's slightly faster than the K810, which was the common computer. It may not be faster than the KL10, which was the fastest ITS computer. We haven't measured it exactly.
On the demo you did, when you used Telnet to connect it, was that just like the serial port emulation of the emulator, or was that the actual TCP/IP stack inside ITS?
So the question was, when I did Telnet, was it really TCP/IP or a serial port? And the answer is we don't have TCP/IP for that version of the emulator yet. We have others that do. So this was a serial port simulation.
That FPGA PEP10 implementation, is that complete and available, or is it in some sort of development stage?
It is complete, and until recently it wasn't available, but now it is.
All right. Where can we get more information about that?
Information about that FPGA, well, it's not exactly advertised, but I know, so you can ask me.
Okay.
Anyone else?
Yeah, I thought there was another FPGA project before this one.
Right, there was another FPGA project before, around 2001, I think, but that never finished. So we just have one today. Any more questions? Yes.
The clock on there said 19 for the years. Is it like year 2000 or where? I was just curious. Remember, you had one of the screens you showed. It said today's date. And it was 19 for 2019. Is it actually 2019, or is it just like that's calendar work? I guess.
Okay, about the ITS idea of time. It does know it's 2019. It has at least 7 bits of year information starting from 1990. So that gives us a few more years until it wraps around. And there may be a few more bits to squeeze out. But we had to fix this in a few places. So initially it didn't show nice dates.
Is there a public public access ITS system available?
Is there a public ITS available? Yes, there is. The one started in 2001 is still available. And we have a few more up and running, which is more experimental, which you can toy with if you like. Again, ask me for information. More questions? Mr. Greenland, were you happy with the presentation?
Yes, thank you for a very good presentation.
Do you want to add a few words? This is Richard Greenland, who was one of the hackers that made ITS. Here's the microphone.
Can you hear me?
Yeah, there you go.
Okay. CTSS was actually slightly later than shown. The original Professor McCarthy left MIT just the same year as previous to me, showing up as an undergraduate student in 1962. So there had been a demonstration of a thing, a project leading to CTSS on a 709 in Building 10. It was an Axiom version of the 790. And it was had previously been a campus-wide resource, but it had kind of been retired. And they did a 2-week demonstration. I understand. I never actually saw this, but but they did some kind of a preliminary illustration of time-sharing system. That was the thing. It wasn't a full-time running time-sharing system. It wasn't really fully functional or existent, I believe. But I showed up in '62, and the AI lab was still in building 26, and Peter Sampson wrote a project to the office of a proposal to the Office of Naval Research, which funded it, and that resulted in the establishment of Project MAC, Multiple Access Computer, Machine-Aided Cognition. The building at 545 Times Square was completed. It was originally intended to be an IBM stretch, which was a failure. Unfortunately, got canceled before it wasted an incredible amount of time, and so that was good. And basically, the following year, the AI lab and the rest of what was the CTSS project moved to Tech Square. Was on the 5th floor of the floor. And they duplicated the 7090 at that point. So the 7090 was the campus computer. It was in building 26. It had a special build out which survives in the present day. It's just classrooms now with the physics reading room and various things at various points. And basically CTSS began to come to life as a real functioning time sharing system that ran on the 9th floor. And it involved duplicating the memory. The memory didn't have protect and relocate or anything. It had a 32K, 36-bit memory, cost $1 million, and they duplicated another one, so now we had two memories, and the system could run ran in one, and it could stand alone root, it ran in one, and the user in CTSS ran in the second memory and so-called compatible system. And so ITS was the incompatible time-sharing system. And the CTSS could run a batch job and could take an original tape, or I've even forgotten what they called their TSS, it wasn't time sharing, it was a mag tape thing with the cards, and basically theoretically you could run that under CTSS. Okay, so anyway, that was considerably later than '62. I only got there in '62, and my freshman year I was just discovered computers around Christmas time, and I had gotten all interested in computers in my early club, and it was the following year. After 2.5 years, I dropped out and went to work with the AI lab full-time essentially. And actually, that's a little bit of a story to go into a little bit. Anyway, Professor John McCarthy was in the real head of time sharing in this way. Of course, for many years, and Stanford kind of drove towards a multi-user, many users. So they had the data disk thing with 64 channels, and everybody had TVs, and they had a video switch, and they had a Libroscope drone, and they had a bunch of attempts to spread time-sharing thin among a large group of people. MIT in those years was more of having more resources directed toward fewer users, trying to run larger programs. SureBlue was most program. Was a large program, and I was involved in PDP-6 Maclist.
I'm sorry, I think we may be running out of time. Do we have any questions from the audience to Mr. Greenblatt? Nothing?
Sure. Who did you look up to there at MIT?
But the question is, who did you look up to at MIT?
Well, head of our group, of course, was Professor Minsky. But he wasn't actually that much of a computer. They wrote one notable program in C# which is a display hack. Well, and other people come. Warren McCullough was around, and various people, but I didn't really know very much about what they were doing. Or Pappert started the railroad companies like that. But I arrived at just the right time, and was pretty tried to make it work. We tried to support this people who were doing research, and there were other a guy named Jack Dennis was my freshman advisor actually, and just an academic wise. And of course, since my first year I was on the dean's list, but after that my grades were long. So, and Jack Dennis was a faculty advisor connected with the TX0 and the P1 that given right at MIT. And then they later developed a so-called PP1X timesharing system. So there's a guy named Peter Deutsch who was the son of an MIT professor, and he would actually do more about computers than most anybody at the time. So phobia about computers. Don't touch the hardware. It was a big role, and also the designer of the P1, a guy named Ben Gurley, was also a funny guy, and he supposedly was drunk when he did it, designed the computer over a weekend, and there was initially there was an element of mystery about it. People really didn't know how the P1 worked at a certain level. It was very elegant and simple at another level, so it wasn't a problem. But, so who did I look up to? Well, I mean, there's a reading room. I read the reports of the Whirlwind project, and they had monthly, and it's kind of bow by bow. They were installing port memory. They were doing various things, and I read about that. And I'm probably forgetting some other things. That's a moment.
Anyone else?
The only place I know where someone can come from Europe to give a presentation and get crashed by Richard Greenblatt. Another round of applause. Thank you.